What is the greatest number mathematicians can imagine? Part 2. Using exponentials, we can write really large numbers like the Google or even the Googleplex, a number so large that we could not imagine it. But we can write even larger numbers by going one step above exponential and using towering. Like multiplication is a series of additions or exponential is a series of multiplications, we will build a tower of exponentials. Let's take 3 exponent 3. Instead of writing 3 exponent 27, we could write a tower of 3 with 3 levels, which is 7,625,597,484,987, or 1,000 times the number of humans living on Earth. A tower with 4 levels is already bigger than the Google number, and a tower with only 5 levels of 3 is bigger than the Googleplex itself, a number so big that we can't even imagine it. The computer scientist Donald Knuth introduced a notation with a double arrow to write only the number of levels in a tower. It means a tower of 3 with 5 levels. But what if the number of levels in a tower is so big that we need a tower to write it? We will simply add one arrow. This could be translated as a tower of 3, where the number of levels is itself a tower of 3 that's 3 levels high. On his blog, Wait But Why, Tim Urban calculated that if you wanted to write this number directly as a tower of 3, the written number would go from the Earth to the Sun, 150 million kilometers. But remember that only the first few centimeters, the first 5 levels, are already worth more than the Googleplex itself. And this is with only 3 arrows. If we take this number and make it a number of levels in a tower of 3, we have something pretty enormous that we could write simply with 4 arrows. Mathematicians called that number G1. G1 is, of course, unfathomable. But let's write G2 as the same number, but this time with G1 arrows. Yes, we can't even imagine the number of arrows. G3 will also be the same. 3, then G2, arrows, then 3, and so forth until we get to G64. G64 is called Graham's number, discovered by Ronald Graham. For years, Graham's number was the biggest number ever used in a mathematical demonstration. Even if each atom of our universe were a universe full of atoms, which were themselves full of atoms, we would be nowhere close to what this number could mean. When it comes to numbers, mathematics have surpassed what our human minds or even our whole universe could imagine.